Those of us who've worked in green buildings for a while have been aware that we cannot make huge strides in green buildings and in energy efficiency, in decarbonization, in resilience. We can't do it with tiny steps, with incremental steps. We have to take giant leaps. We have to innovate. And so that's what this panel is all about. We're going to be meeting some of the people who are innovating, and they're going to tell us about the technologies that they're working on, and it's very exciting. And so these are the types of technologies that you're going to find in deep green buildings and not those pale green buildings. Thank you, Chris, for bringing us that vocabulary. So no pale green for us. So our first panelist is Pete Baldwin with HARNYSS.
Thank you. Thank you very much. I've used GRUNDFOS pumps on groundwater remediation projects for so many years. Back in the 80s, as a matter of fact, but I'm not part of GRUNDFOS. I'm actually with a company called HARNYSS. So the screen, it's not true. Okay. So I'm with HARNYSS, and what I'm going to want to talk to you about is energy storage. When people think energy storage, it may be in your phone. It could be in your home, where you probably depend on lithium in a big way. We know that lithium has its tremendous advantages. We also know if we push it too hard, it's going to heat up, whether you're downloading too fast or you're charging it too fast. Lithium will heat up. When you have lithium, and I'm not here to bash a great technology, but when you have lithium, you also know that in a short amount of time, you're probably going to get a new phone because the battery's no good, more than the technology. Lithium in a utility scale or a larger scale like would be in a building, you're probably going to get 7 to 10 years out of it, no matter how you run it. If you run it extra hard, you're going to lose time, but you also have to worry about it overheating. And putting a battery in your building or your community that could get what's called thermal runaway would be a huge threat to your asset. And so our company called HARNYSS, we're based in Fort Worth. If you ever want to come by, we're west of Fort Worth in a building that has solar on the roof, and we use our technology to run our operation off-grid 24/7. We manufacture both hydrogen storage. We can manufacture the components that in a remote area we pull water out of the atmosphere, we deionize it, we electrolyze it to throw more terms around, and we make hydrogen on location without a compressor and store it and use fuel cells to make enough energy to run a battery or a small operation. But what I'm here to talk about is the other side of our product line, which is called supercapacitors. So a supercapacitor is like a capacitor. It'll charge up, it'll discharge very quickly. With the new supercapacitors that are no longer filaments and ceramics and things, we actually make them out of graphene, which is a type of carbon. So it's a very, very low footprint, very small footprint for supply chain to make them. We operate, of course, with zero carbon, and then when it's time to dispose, rather than the 10 years, 7 to 10, maybe 12 for lithium products, will last 25 or 30 years. And when it's the end of life, you don't have a hazardous material to transport to a recycler, we're carbon. You can dispose of us. We're 100% recyclable. It's a really cool product. So we're working with a number of developers and whatnot, where we take our product and we put it into a shipping container, if you know what I mean. On the end of a train or a truck, you'll have a shipping container, 20 foot, 40 foot. We can put 3 megawatt to 4 megawatt hours of storage in a shipping container. And with enough room, we'll put all of the switch gear, all of the inverters, all of what you need to build a microgrid in a box. And so we have a unique product. It's a microgrid in a box. So now we have a plug and play that could be shipped to a solar field. If it's utility scale, we can go from a megawatt hour up to 100 megawatt hours or more. If it's in a building or somewhere, we make them so it fits where the needs are. And after talking about potential fires with lithium, and you could look and see pictures of Teslas. I'm not picking on them. Everybody else is, but today I'm not. Tesla's on fire. Buildings, places with lithium on fire. We don't have that problem. So now I ask, would you put supercapacitors that don't catch on fire? We don't even heat up. Would you put those in a building, or would you put supercapacitor, lithium batteries in there. So that's what I'm here to talk about, is the benefits of long duration energy storage with the applications of microgrids, which we know the microgrid is like the grid, except we can either operate attached to it and then disconnect and be what's called islanded, or we can just run off-grid far away. We work with native tribes. We work with islands in the Pacific. We have a site in St. Kitts, the same thing. We basically have a power source and we attach to it, and we're the microgrid. So I'm part of TCU. Actually, I graduated last year from there with an MBA in energy because I wanted to be the oldest person in the school. And it worked, because I still am. I'm older than the professors. But at the end of my career, I did my bucket list thing, and it was great. Got involved with this energy. We're involved with the country of Suriname, which we're putting in. They've designed a site where you can see Suriname in South America. It's at the kind of the hump. It's in between Venezuela and kind of the backyard is the rainforest, the Amazon. So they claim to be the lowest carbon country in the world. What happened to them, which is great for their economy, but they discovered a tremendous amount of oil offshore about 5 years ago, and they're starting to build the economy based on that, and they're building it out. They're going to produce oil probably in 2029 or 30. In the meantime, they need to house their expatriates, their specialists, whatnot. So the country doesn't want to carbonize their transportation, and they don't want to carbonize their electrification. So they've come up with a 40-acre parcel. I'm missing my pictures, but they've come up with a 40-acre parcel that is going to be constructed to a LEED community standard. It's going to have solar on the roof and on the carports. It's going to have one of our units, a 40-footer, probably a couple of megawatt hours of storage, and we're going to be the grid, the microgrid. We'll be attached to it if they need it, but what they're going to run also is power over Ethernet, if you know that. There's a hotel in Fort Worth called the Sinclair, if you're ever interested. They run probably 40% less expense for electricity since putting it in. We're looking to maybe bring those folks in to put in power over Ethernet, because not only is it less cost, but when you have solar and you're running it, it's less demand. So we're going to be putting in a rooftop solar EV canopy so we can run EVs. We do level 3 charging with our technology. And then with the power over Ethernet, it's going to be smart grid, et cetera. AI comes in, so you get your data, you get your power, and you get security information, everything built into that. So it's not going to power your HVAC, but it'll run the controls and do a lot of the heavy lifting. Our technology can handle AC or DC, or both. It's completely fine. It's terrible that I'm missing my photos, but we're going to pretend you can see pictures of this community. But yeah, I'm so sorry about this, and that's okay. But going in with the circular economy principles, water, gray water management, we're obviously coming at very low energy, and we're able to bring with this a design that not only is going to work for the expat community with a hotel and conference center, so the people can come into town, all have their meetings there. There's housing and retail mixed use, not just for the expats, but for the locals as well. And there's going to be an international school. I've lived in Australia a couple of years, brought my kids. Expat community, you got to put your kids somewhere. They have these international schools, and it works great for the locals, and everybody mixes better. It's a great acculturation. So with that, we're working with TCU, which is the sponsor, along with their university in Suriname, working with the equivalent of the Department of Energy, the utility, and also their basic energy chamber. So we're coming together to get this designed with a local firm, and I'm not going to have any pictures, but as far as all of this microgrid will be able to be a blueprint for building a low-impact community, staying with with low carbon, which is their objective, because as they grow, I mean, they're basically going to have, they're well educated, but they're not a wealthy country. They're going to become an extremely wealthy country, and all the money is going to go into a sovereign wealth fund. And with that is the ability for them to stay low carbon, and that's what they're going to do. And so this is going to be shared out with other communities, other countries, and in the Caribbean as a blueprint. And that's how is this going to do. I'll finish with just showing what HARNYSS does. We work with communities, military, data centers. We can plug into the grid and stabilize grid signals. I've never tried to cram 20 minutes into 8, and I did it. So thank you all very much.
Is this live? Yes, I guess. Here. Thank you very much. So, and we did get a few pictures here at the end, so that's a good thing. So, sorry about the pictures not working, but it's always good to have those. Okay, next we have Tim Greer, and he is with GRUNDFOS.
Thank you, Tricia. I want to thank EarthX, and I want to thank Jonathan and USGBC specifically for including GRUNDFOS. My name is Tim Greer. I'm the Regional Training Manager for GRUNDFOS for the U.S. and Canada. I'll ask that we can advance the slide, if that's okay. Oh, yeah, of course I do. So before we go in. All right. So I want to quickly talk about some of the cool things that GRUNDFOS is doing throughout the world, and a little more specifically here in the U.S. Do we have design engineers? Any design engineers? I got to see a couple. Any civil engineers in the room? I always found that the civil engineers are the really friendly ones. Think about that. Okay, so somebody laughed. All right, so our promise, if you don't know who GRUNDFOS is, we are one of the world's largest leading pump manufacturers. And I'll get into some details if you don't know about us here in just a moment. But our promise is to pioneer solutions to the world's water and climate challenges and improve quality of life for people. And our promise is to respect, protect, and advance the flow of water. And everything I talk about really comes back to those two things. Some fast facts about GRUNDFOS. We are, as I mentioned, one of the largest pump manufacturers in the world. We were founded in Denmark. We are Danish-based by Paul du Jensen in 1945, way back in 1945 in my best Casey Kasem voice. You young kids can Google that, who that is. We came to the U.S. about 52 years ago. We celebrated 50 years in 1973 here in the U.S. We are owned, 87.5% owned by what's called the Paul du Jensen Foundation. Now, this is a big deal because the charter of this foundation is very strict, dictating how we run our business. And for example, 5.4% of our revenue must be reinvested every year back into innovation. Innovation leading back to that promise and what we were just talking about, those advancements specifically in sustainability. And you may be thinking 5.4%, maybe not a big number, but when you consider that GRUNDFOS is a $5 billion company, it's a pretty significant amount of money every year. And that's revenue, that's not profit that we reinvest. 15 million units produced per year. We have about 15 sites here in the United States, about 20,000 employees globally. And the big one I'm going to talk about on the next couple of slides, we are the first water solutions company with a net zero target of 2050. And if we go a little bit deeper on that, you can kind of see the trajectory that we are on. Our baseline was established in 2020. As of 2022, we were already 12% below that baseline. By 2030, we hope to be 50% below in scopes 1 and 2. And if you want to learn more, I would encourage you to come and see me or Abraham De Leon, who is our sales engineer for the Texas region as well. Big hats off to him for joining us as well. And then 25% below that mark, that baseline in 2030 for scope 3, with the goal of hitting all full net zero by 2050. And how are we doing this? 4 quick points. We're reducing our own water footprint. If you are from Texas, if you're in Texas, specifically in Houston, I would encourage you to come by our U.S. headquarters in Brookshire. If you don't know where Brookshire is, it's a little bit west of Katy. We have a LEED Platinum version 4 building. Our main campus office building opened in 2021. It was the first LEED Platinum version 4 building in the state of Texas. And we actually give tours on this, so come and see me and talk to me if you would like to come and check that out. A lot of cool things. 87% of our water is rainwater, for example. Over 100 solar panels between electric and water, hot water, and all sorts of other things that I can go into if you come and do a tour with us about our building. Safe water access across the world. If you are familiar with Walk for Water, we are a big participant and sponsor of Walk for Water throughout the world, getting water to those in parts of the world that don't have easy access to water. Efficient water use, wastewater management, and optimized water treatment and reuse, and I'll touch on some of those things over the next couple of minutes. Now, GRUNDFOS is divided roughly into 4 divisions. I'm part of the Commercial Building Services division. We also have domestic, water utility, and industry. What we do in the Commercial Building Services has to do with comfort in a commercial building. So if we are moving fluid for comfort, such as hot water recirculation, pressure boosting, HVAC, boiler, chiller water movement, wastewater management, that's what we're doing, Abraham and myself and our division, that's what we're doing for Commercial Building Services. So the question is, how can GRUNDFOS help lead the sustainable agenda? And a lot of people don't realize the consequences of an inefficient HVAC and water system can actually increase energy usage by 54%. When you think about buildings, we've heard a lot about this today, and I think I'm in a room full of people in the choir, right? So preaching to the choir a little bit. So a lot of you guys understand this statistic when we talk about it. But a lot of people don't think about the pump. So when we talk about GRUNDFOS being a pump manufacturer, when you think about mechanical rooms, and I've been in the mechanical industries, different parts of the industry for about 20 years, a lot of people don't think about the pump. They think about the boiler or the chiller or whatever the biggest piece of equipment that's in that room, maybe the hot water devices that are in there. But the pump is at the heart of the system, and they can impact things you see here, right? Great comfort and safety, overall building efficiency, operational expenditures, and even asset protection. So I want to quickly talk about GRUNDFOS intelligent and reliable pumping solutions. And I've got 3 things I'll touch on. And again, please come and talk to us if you'd like to learn more. And you can see the banner in the back talks about distributed pumping. That's a big message of what we talk about with HVAC systems, specifically boilers and chillers, is distributed pumping, and that's been done in different parts of the world a lot more than we're doing it here in the U.S. The technology has finally caught up with the concept, and this is a big part of what we talk about. As when we talk about water movement in boiler and chiller applications, the traditional way to do it is what we would call a primary-secondary. Distributed pumping takes it to a little bit a next level. So I'll give you a teaser and say, come talk to me and learn more about what that is. Also, intelligent pump solutions that can optimize buildings' capabilities for on-demand boosting in HVAC. We offer modular pumping, multi-pump skids that we build in our factory, and we can ship it to the location, install it. It has our controls that ensure the pumps are going to run in the most efficient manner, and we can deliver reliable HVAC and pressure boosting solutions that can automatically adjust to changes, making sure it's running in that best efficiency point that it can when we talk about pump curves. Come and talk to us if you'd like to learn more about that. A quick example is our motors. A lot of people don't realize GRUNDFOS is one of the largest motor manufacturers in the world. We make most of our own motors that drive our pumps. And the standard for motor efficiency is what's called IE3 by NEMA. We actually operate 2 levels higher than that at IE5. So up to 10% additional energy cost savings with our motors in VFDs. So intelligent pumps can reduce energy consumption by 25%. That's a big number compared to standard solutions. We're excited. In about a month, we're going to launch the next generation of pump selection software. So when I asked if there were any design engineers, if you'd like to learn more about this, come and talk to us as well. GRUNDFOS Select not only will walk you through easy selection of pumps and pump systems and water solutions, but it's intuitive enough to say, hey, there's a better way to do it. And let's give you another alternative to make sure you're getting the most efficient, sustainable choice. Another unique thing about GRUNDFOS is that we have an energy optimization team throughout the US and Canada. Now, this team can come out and do to any commercial building what we call an energy audit, a detailed analysis of a building's energy network, and then they can offer recommendations to help realize the potential savings and energy efficiency that could be happening. I've heard a lot of great stories about that today. There's some cool success stories from this group out on YouTube. Again, you can get with us as well. And the final slide I'll throw at you is one thing that I'm charged with as regional training manager is what we call the Sustainable Buildings Academy. And this was a vision that was seen by our leadership a few years ago. I came on about 2 years ago to help start building the Sustainable Buildings Academy. And it's training, but it's not just about product training. Of course, we're going to be training about GRUNDFOS products, but it's a bigger picture than that. It's about partnering with entities such as ASHRAE, ASPE, USGBC. Big hats off to USGBC. We do a monthly webinar. They joined us back in February to talk about the new LEED version 5. In fact, you can find that on our website, the recording that Maria Perez and Andre Lair joined us on that. Other things we're doing, we do, as I mentioned, monthly webinars and live courses coming soon, and we have e-learning out on our website. Would love to tell you more, guys. Pleasure being here. Again, big thank you to Jonathan Kratz, to the EarthX folks, and to Tricia. And come and talk to us if you need to. Have a great show. Thank you.
Thank you very much. And next up, we have Riley McKillop with Autocase, principal economist with Autocase, right? You.
Alrighty. Good afternoon, everyone. And yeah, whoever saw the panel presentation earlier on this morning, it'll be a little bit different. We'll dive into some more of the economic considerations that we are speaking towards in terms of some of that value and being able to speak more of a business case language and being able to provide a bit more rigor in terms of how we approach building design. So as mentioned, I'm a principal economist. You guys might be wondering why an economist is dealing with building design. So where we really come in is being able to measure performance and being able to measure ultimately the cost effectiveness of various investments. So our company Autocase is ultimately a team of economists, software developers, and data scientists, and we build software tools to enable design teams and building owners to advocate and also help inform their design through a more holistic framework. So the main product that we'll be speaking towards today is our business case software called Autocase. So when you're approaching sustainability or different ways compared to conventional design, justifying the economics or justifying the business case can be pretty tough sometimes if you don't have tools that they're ready to in order to be able to speak to return on investment or what type of payback period some of these investment strategies have. So Autocase was purposely built to help identify, quantify, and monetize the direct cost and benefits in terms of financial impacts from utility rate savings, upfront costs. But where we take things a little bit different and take a step further is really being able to identify, quantify, and monetize co-benefits. So things like social and environmental impacts that traditionally have been left outside of the, let's call it financial pro forma. And we're really able to measure things on an apples-to-apples basis using ultimately dollars. So this is what we'll get into today. But before we go ahead and get into triple bottom line or any type of economic analysis, I figured setting the stage would likely be useful here. When we think about the impacts from green buildings, they're very wide-ranging in terms of the impacts that they can have, both in terms of benefits as well as costs. If you don't make very mindful decisions of how you approach building design, you're ultimately introducing a large community burden that the folks around the project site ultimately have to deal with. So when we think about building design, or if you hear, well, what's this going to cost? Really, the financial impacts from green buildings are really just the tip of the iceberg when we start ultimately trying to identify what are the major drivers across green buildings. Below the surface, so below the upfront costs that you might be hypothesizing, there's really broad implications of both society and the environment, which we're able to capture and really incorporate a part of this business case framework. And this is what we'll spend a bit of time on today. So when we think about a new construction, this particular graphic here is very much focused on those LEED credits. There's many different areas that we can overall influence the building design and generate long-term value. So in the lens of, let's say, a new building, energy and atmosphere, we can be more mindful about how we use our energy consumption, what type of fuel sources that we potentially will be using on site. That has direct impact. So if we avoid kilowatt hours, we're going to be avoiding, let's say, local utility rates that we'd otherwise pay to our provider. Above and beyond that, we're able to quantify and monetize the avoided greenhouse gases as well as criteria air contaminants or air pollutants. Greenhouse gases typically get a lot of the, I would say, kind of news headlines, but air pollution has much more regional impacts. So being able to reduce our energy and reduce our associated air pollution has very, very big health impacts in terms of the local community. So we're able to, again, marry up the direct kilowatt hour save, but also speak to the avoided emissions by using various social costs. Another example is water efficiency. So when we think about saving water through more, let's say, efficient potable water fixtures, excuse me, again, that'll have direct impacts in terms of avoiding utility rates for our water use. What a lot of folks don't realize is that the water that you consume actually has a lot of embodied carbon in it. And what I mean by that is that it takes a lot of energy to pump, treat, and convey water to and from the project site. So by being more mindful about how much water we consume, we can reduce the energy associated with treat, pump, and conveyance to and from the project site, which we're able to quantify and monetize. The other big thing with water is water availability. So depending on where you're located across the US, you might be sourcing your groundwater or your overall water supply from groundwater, surface water sources. By maintaining a sufficient water supply, that's an economic benefit, which we're also able to introduce to that business case framework. The next one up is indoor environmental quality. So we have a big opportunity to generate value and really create more spaces that are more conducive for the overall occupants that are going to be residing there or potentially working there on an 8+ hour basis. So this is where we can get a bit more tactical in terms of some of our enhanced ventilation strategies or filtration and being able to provide that business case in terms of really speaking to those occupant-driven impacts. So things like improved occupant productivity. Ultimately, if we, let's say, improve the indoor air quality from the space, that reduces health impacts, and then we're also able to speak to absenteeism. So all I'm pretty much trying to say here is that the way that we traditionally approached business casing or overall measuring the impact associated with green buildings have very much been focused on the financial impacts, but really there's a much more broader story to be told, and a lot of the value is actually created from that below the surface impacts. So what Autocase ultimately does is conducts a triple bottom line analysis. So we're able to speak to take in various design strategies as it relates to energy, water, sustainable sites, indoor environmental quality, speak to those direct financial impacts in terms of utility rates, life cycle cost analysis, et cetera, as well as marry on those additional co-benefits in terms of quantified, monetized reductions in greenhouse gases, air pollutants, speak to any type of recreation amenities that might be introduced on site if we're going to be, let's say, installing more amenities as it relates to community gardening. And then very similarly on the sustainable site side, if we're going to be swapping out impervious black surfaces with more greenscape, we're also able to speak to the differences in urban heat island impact. So a very large overall burden that's placed on the community from having ultimately too much solar radiation around the project site. So the real value with using a tool such as Autocase is that we're able to quickly justify some of our sustainability attributes. So we're able to kind of automate this business case process. So in the back end of Autocase, we have location-specific data points. So if you run an analysis in Buffalo compared to, let's say, Tampa, Florida, you will receive vastly different results, and that very likely should lead to that, just given to the differences in the markets, utility rates, et cetera. So we're able to kind of speak to those very location-specific elements as it relates to the business case, as well as project in the future what type of impact that might have over a 25, 30-year period, and discount those back in today's dollars. The other major piece to conducting a triple bottom line analysis, if you're ever going through any type of green building certification, we have a lot of credits available for actually just conducting a triple bottom line analysis. So under the V4 and 4.1 frameworks under current lead, 2 credits available just for actually doing this exercise and reporting on some of those outcomes. We also are very excited with the new advancements in LEED V5, project priorities and innovation credits. Those aren't quite finalized yet, but triple bottom line analysis is expected to play a role front and center in those new innovation credits. So ultimately, I'll leave it here today with really just saying that there's scalable software solutions out there that can help enable design teams to speak that business case acumen. So being able to speak to ROI, being able to speak to what type of payback period might ultimately stem from some of your building design attributes. And the way that we do that is by using economics. So by being able to speak to who has standing from a building owner perspective, building occupant, as well as a building community, we're ultimately able to formulate a more holistic business case framework and then report on and ultimately justify some of those design attributes. So thank you very much and have a good.
Okay, our next speaker that I'd like to introduce, Thomas Mende with Binderholz Timber.
So I've been here, this is my third EarthX convention. So I was flipped over a little bit faster and don't want to bore you with what I've talked before in the previous session, so you can find those online probably. But does anybody here not know what mass timber is? Everybody knows it, so I don't have to explain that. That's perfect. So what I wanted to show you then quickly is what we've been working on the last few years, and actually the last year, and what's special about some of these projects. So this is the latest project that was just completed in Baltimore. It is the new headquarters for Under Armour Corporation. It's an extremely unique building design because it has exactly one steel beam in the entire building, and that is to support an open staircase. So if you ever want to see a real wooden building, with the exception of the glass that's surrounding it, this is a great case study and would make a nice trip. So two things that are becoming more and more interesting in the mass timber realm is what you see here. One is just a warehouse solution. So people say, why warehouse? Well, it's basically a very similar concept to tilt concrete walls and very quick construction, of course. But again, a warehouse that will help you with the environmental footprint of the overall building. And just a minute ago, I met through this great convention some folks that were building data centers. So data centers is kind of the next realm, again, on mass timber. As you probably know, data centers use a tremendous amount of energy, and this really helps with the credentials. So these larger buildings, these quick erections of some very large facilities may not use a lot of mass timber panels, but certainly on the glulam side is expanding quite a bit. So this project is now in the final stages of completion. If you ever make it to Luxembourg, everybody knows what Luxembourg is famous for. You know, money laundering, keeping tax evasion, and storing very valuable goods. But this is the new Luxembourg airport. It's the largest mass timber project ever built in terms of overall volume. And it uses a hybrid scenario with steel, concrete, and mass timber. So, but what I really wanted to focus on is actually the B solution work that we do, which is, of course, something that should be on everybody's mind. We have all these issues with wildfires, and aside from that, an underbuilt housing environment of about 3 to 4 to 6, depending who you ask, million units that we're short over the last couple of years. So we use this, we have a system we call B Solution. This has taken mass timber to a very quick design project with finished wall components, bathroom components that are just assembling basically on site. So to me, this is the ultimate to what somebody described to me on a job site recently is mass timber is really just IKEA with big pieces. You know, you just kind of, you got your hardware, you got your big panels, now you're screwing it all together. So this is the next level. You know, I've bypassed the finishing work, I bypass all of that because all of that is now done pre-stage, pre-installation. There's a few different options that the customers can select. You know, what kind of ceiling do they want, what kind of roof do they want, and so on. So they can just select all this on the software piece. Then we build the bathrooms. there's 4 different bathroom box. We call them B box. B for Binder, it's very innovative, B. So these boxes can be then stacked basically in the core of the apartment building, and they just sit in, and all of that is already installed, so it's finished. It's basically a ready-made solution for the job site. And fire protection, everything is basically included. The electrical panels are built, so it's just stack and click. And this is what it looks like afterwards. Windows and fittings are already in. Again, the customer gets to choose a few things. So, and we're digitizing, of course, in the production. And this kind of looks like a typical manufactured housing sort of scenario, but it is really essential. You see the CLT panels up in the front, and they now get built up into these finished wall panels with exterior and interior cladding. All the openings, the windows are being placed in it. Here's the bathroom box during construction. By the way, it's a good shot to see what cross-laminated timber is about. You can kind of see the different grains running. It's delivered to the job site on lorries, taken off, disassembled again. In this particular project, you can kind of see what it gives you. This is just a 2 or 3 story building. So this is, of course, there you can see the finished panel, the box being placed, and then it all gets assembled, screwed together, and it's finished within absolute record time. Now, the really fun part about it is that it's extremely cheap. So if you can imagine where we are with building costs now, I'm not going to name the number, but it costs about the same thing that building would cost us in the 1990s per square foot. So it's an extremely good, quick building solution that takes the mass timber level side to a different level. That is the multifamily and apartment side. And this could, of course, be replicated. If you have the great idea to copy us, I'll be happy to sell you the panels. Thanks a lot.
Thank you, Thomas. All right, and now I want to invite to the stage Jeremy Sigmon with PowerStack.
Hey, everybody. Thanks very much for having me. Thanks to USGBC Texas for putting this together, Jonathan, and to the other panelists for being here. I often talk with my fiance about why we're so exhausted on the weekend, and it does seem like caring costs a lot of energy, right? So I think all of us in here have been caring a lot about the careers of impact that we're all trying to have. I myself have been in one for the last 20 years or so. I actually started in solar. My company now, PowerStack, which I'll talk about in a second, is back in solar, but I took a little journey, and it was all in search of impact. I started by looking at a building like a residential house, and I was up on rooftops clamoring around trying to figure out, well, how does this work, and how is this system put together in a way that could be more sustainable? I learned about this thing called LEED, where we can take excellent ideas in energy and water and health and transportation, location efficiency, and stick it all together in one coherent concept. And in 2000, I was working on the world's first green residential high-rise. I got excited enough about that I decided, well, how do we scale that up? So I decided I wanted to work in Washington and try to move some of the people and the policies to make more of the kinds of technologies and designs we've been talking about today happen. Of course, if you've ever worked with government, whether state, federal, local, et cetera, you can probably find yourself fairly exhausted at certain points. So after a decade or so of that, I decided I wanted to look for a new form of impact. And so I thought, well, why not manufacturing startups? Pretty exciting in modular housing, high efficiency, net zero seeking, et cetera. And I recognized that, well, there's this whole new side of the built world that I hadn't been thinking about. And if you look outside, you recognize that there are thousands, if not millions, of poles. And it's not an area I'd really thought much about before, and yet these are power-hungry pieces of infrastructure all across our landscape that are constantly consuming power. And what they're also doing is they're providing an answer to a solution provider for power exactly where you need it. And so my company, PowerStack, which I lead the US division of, we're sort of bi-national, bi-coastal between the US and Australia, and we work globally. We're solving power supply and power access challenges for landowners that need a technology located in one particular spot and they don't have power for it. Now, that's not something I had thought much about before. I think what's exciting about it is that there aren't a lot of good answers. The current answer that most people go to is you dig a long, expensive, and often complicated trench, and you run copper wire through it, and you make a big mess, and often your contractor will tell you, well, it's only going to be 20 bucks a foot. And then there's a tree root, and then there's a heritage, burial site, and then there's a rock, and then there's a city sewer pipe, and suddenly you're spending, $60 to $80 a foot. And you've got all that copper, and if you look in the news once in a while and you follow infrastructure news, like I do, you'll see that people are stealing that copper wire like almost as fast, like, the Golden Gate Bridge that's painted, and by the time they get to the end, they have to repaint the other side. The same thing is happening on highways across the US, where they're wiring street poles for lighting, and then they have to go back and rewire them because folks are stealing the copper. So there's a lot of challenges about why we would want to think differently around installing outdoor power supplies. And of course, if you move towards solar, there's a lot of opportunity. There's a lot of things out there, but usually you have to kind of build it yourself. You have a panel, you have a battery box, you have things that people like to steal, and things that people love to hate. And so we thought we would just try to do it really differently to make it a heck of a lot more resilient, a lot more interesting and attractive, and also made here in the USA. And so rather than being railroaded with an option like I have a light with a pole and you only get that one design, we thought, why not build a power supply that's an easy place to mount your outdoor solution? So I'd like to introduce to you PowerStack and show you a little quick video of what we do and how we do it. So we're reimagining the concept of solar integrated into the outdoor environment. We can do this vertically because vertical surfaces capture light at all angles throughout the day, especially in winter low-angle sunlight. We're getting rid of this concept of digging up the streets and digging up the parklands. We have the opportunity to rely on solar and battery storage and put it pretty much anywhere the sun shines. We're doing this in a manufacturing facility in the United States and in Australia. We use a diamond pile, concrete-free foundation and a winch system to allow this to move into place at record speeds and with high safety. We beat the heck out of it, even shot it with an AR-15 because we are in Texas, and we're building something that's pretty damn durable. And people love it in their neighborhoods. They like it in manufacturing, kind of industrial landscapes. We're working with cities and with different people who are basically landowners across the world. And so folks often ask me, why are you doing it this way? Like, why integrate it vertically? Why make it in that format and profile? Why is the solar panel facing the opposite direction than I would have expected? Well, there's a lot of answers to those questions, and in 4 minutes I can't answer them all. But quite simply, the low-angle sun in the winter allows for a vertical surface to be far more efficient. It's an optimization of form and function. But you also have the big challenge on project sites, if you're in the design world or the construction world, where not understanding which way the sun might be pointing allows your construction and installation crews to possibly implant your solar in the wrong direction. And so if you have something with vertical surfaces, you can rotate it at 360 degrees, and we model it for the best performance in any orientation. And it also takes a pretty talented bird to shit on a vertical solar panel. And so we can keep it clean. And if you happen to notice that it's polluted, it's pretty easy to access and to clean off. And so because it's modular, we allow the ability to have a 3-foot version up to almost 30-foot tall version. And if you're in a really sunny location, you have surface area to recharge your batteries that might require a bigger battery bank. But if you're way up north, you need a lot of surface area and a smaller battery bank. So we can modularly offer a variety of different permutations of a solution that work really well, surprisingly. In Canada, we've got projects in Europe, and we're down along the Mexican border. We're in Singapore, and certainly all over Australia, and moving into the Middle East as well. So we have a lot of opportunity to provide solar power in a really unique and durable format. And here for the US, also made in America. So there's PowerStack for you, and I look forward to talking to you all a little bit more about it and your careers of impact. Thank you. And if you want to see it, I've got it.
Thanks for that. Now, I grew up in Louisiana, and I always said that the sun is our most abundant resource. So I'm glad we're using it. All right, thank you for that. And our last speaker is Eric Zito with Lennox. And Eric just joined our USGBC North Texas Regional Council. We're excited to have you on that, and we're happy to have you here today.
All right, thanks, Tricia. Well, I know today is our innovation session, but the main topic that I want to shed some light on is actually decades old. I will touch on some high innovation, leading edge product towards the end, but there's an opportunity also to maybe be innovative and rethink green and prioritizing some really tangible and immediate decarbonization benefits. So sometimes, when we look to decarbonize, there's an emphasis to how quickly we can get to the zero carbon solution, the ultimate solution in the end. And it can lead to sometimes standing still and not innovating. And so what I'd like to talk about today is a way to really focus on concrete decarbonization that we can achieve. And it's understandable why there's a real priority to try to innovate as quickly as possible and get down to zero, because there's a lot of work to be done. Carbon's long lived in the atmosphere, and we certainly don't want to turn away any opportunities to do that. But within our buildings, as we know that emissions from buildings make up about 40% of our total. And within buildings, nothing uses more energy than an HVAC system for a typical building. So, and energy is a pretty good proxy for emissions. So if you're really looking to decarbonize and want to prioritize your work, HVAC is a great place to start. So what are the opportunities for us, and where do the emissions come from? What levers do we have to reduce those? Well, the first thing I'll touch on is embodied carbon. And so the challenges there are very, very similar to the other appliances. So a lot of good work to be done in that area. But at this point, it's a relatively small piece of the pie for HVAC, so I won't spend any time on that piece this afternoon. The next slice is refrigerant. And there's really two pieces to the refrigerant challenge. The first is just the chemicals or themselves that we use to transfer heat. So they're great at transferring heat. They also have some pretty nasty side effects. All right? So the first one I'll mention is R22. Great at transferring heat, also great at poking a hole in the ozone layer. All right, so we moved away from R22 to 410A a few years ago. So 410A, great for the ozone layer. Unfortunately, it's also a very potent greenhouse gas. Right? So it traps about 2,000 times as much heat per pound as carbon dioxide. So, but also some more good news there. Many of you may be aware that we have recently moved away from R410A in the US as of January 1st this year. And so we moved to lower GWP refrigerants that have given us about a 70% reduction in global warming potential. And it's a good example of something that it's not the perfect ultimate solution, but it's great progress using technology that's available today. Now, the next step for us to get down to 150 GWP and down to 10, those are going to be a doozy. And we definitely don't have time to talk about that challenge today. I'll leave that for later. But the other thing I will mention about refrigerants is it's also important for us to do the best we can preventing them from getting into the atmosphere. So that means reducing leaks, making sure that we're reclaiming refrigerant. We have a program with Hudson where we make it a great benefit to our dealers to be able to reclaim the refrigerant, and we've had good success growing that. So refrigerant is an opportunity, but it's still, overall, is a relatively small piece of the pie. And the next slice is a little more meaningful, and it's one we're familiar with, is efficiency. So we've made some really good efficiency gains over time in HVAC, but it takes a long time. It moves relatively slowly, and you're never going to get all the way to zero, just efficiency alone, right? So I want to spend the focus on the remaining piece, which is the most impactful, and that's electrification. So in HVAC, that means shifting from gas and propane over to heat pumps for heating. And heat pumps are a well-known technology. There's a lot of parts of the US where it's actually the leading technology installed for heating residential and commercial buildings, and it works great. So, all right, so why don't we just move right to heat pumps everywhere, across the board? Well, there are a few barriers to that, which we'll go through. And the first one is just a general resistance to bans, right? So I make it a policy to try not to run headfirst into a brick wall, if it's possible to go around. So we can expend a lot of energy, in bans and trying to enforce things like that, but there is going to be a general resistance. So there are some alternatives to kind of skirt that. Second is technology readiness. So heat pumps, there have been a lot of gains over the years in efficiency, especially in inverter-driven units. But especially at the lowest entry-level cost point, heat pumps are challenged in some of the coldest environments today to really keep up with capacity. So it's not a 100% solution just yet. Also, electricity costs. There are some markets in the US where you switch from gas to heat pump and it'll give you an operating cost benefit. But there's a lot of places, I don't know, California and others, where there's a really high electricity cost and that your transition to heat pump ends up increasing operational costs. So that's a tough barrier to overcome in a lot of these markets. And lastly is grid readiness, right? With load growth we anticipate with AI, electric vehicles, heat pumps would add to that load. Now the reality is that transition is going to happen over time, relatively slowly, as the current stock is changed out. But it is, this shift to a winter peak, is something for utilities to be aware of and deal with. So it can be, a barrier as well. So, the technology, though, I'd like to talk about as a solution here is actually the heat pumps and gas in tandem, which is known as a dual fuel system. All right, so if you have both heat pumps and gas that work together and use the benefits of both of those systems together. Again, it's not a new technology. It's been around for a long period of time, but it has the opportunity to directly address those barriers. It's kind of like a plug-in hybrid vehicle today. It really fits as a transition, and knowing that we're not going to need to get off gas completely eventually, it helps really put points on the board to eliminate carbon in operations. So how does it address those barriers? Well, first, it avoids the gas ban issue, right? You still have gas that's in use, but you're removing it off the table through operating and programming means. So it really, without banning it, it is pulling it out of the energy mix pretty substantially. Technology readiness, well, gas fits in as a backup only when it's needed the most and where it is a benefit at those coldest temperatures. Now, electricity costs, again, gas will fit in and take up the load for heat exactly at that time of the year when you're running the heat pump the most, and it can be the best benefit. We sometimes call it utility insurance because you have the ability to, within the balance point between the heat pump and gas, take advantage of whichever fuel is most cost effective in that geography. And lastly, grid readiness, right? At that time of the year when the utility is going to be most stretched with winter heat loads, it fits in and does a really great job of pulling that heating load, that electric load, completely off the grid for just that period of time. So, what does this look like if we were to think about a current system that was only gas for heat, did not have a heat pump, and as the weather gets colder throughout the year, you're increasing the load in heating covered by gas. But if you have a dual fuel system, the heat pump really shaves off the majority of that carbon or combustion-based load that you have throughout the year. It's still there to pick up the slack at the time when it's needed most, but during the rest of the year, you're achieving true decarbonization. And that's part of the load that's taken continues to get cleaner over time as the grid gets cleaner. So what's this look like in practice? Well, I'd highlight a couple things. On the commercial side of the business, there's the Lennox N-Lite dual fuel heat pump, available from 3 to 25 tons, up to 17.5 SEER2, manufactured here in the U.S. Recently won a dealer design award, awarded by contractors in our industry. Now, on the residential side of the house, if you want to go to the latest and greatest technology, start with the SL22 KLV cold climate heat pump. And this is the heat pump that won the Department of Energy's Cold Climate Heat Pump Challenge. It features 100% capacity all the way down to 5 Fahrenheit. And it keeps running and keeps capacity, or at least minimum capacity, all the way down to -20. So this is a great unit we just launched with a new R454B refrigerant. If you pair that with the SLP99V furnace, so it's both the quietest and most efficient furnace you can buy, this is kind of the ultimate dual fuel system. So if you want to maximize your efficiency gains along with the decarbonization. But the point that I want to make and kind of end with here is that a dual fuel system, it doesn't have to be the top of the line efficiency to get some of these same benefits, right? Even your entry-level heat pump, your entry-level gas furnace will still really help overcome those barriers to decarbonization and start us on the path, right? Change the status quo to where we're not fully being heated by gas, and as technology continues to develop, we're already making gains. So if you're looking to decarbonize buildings and have a real impact today, start with a heat pump. If you're in a geography where it works, that's the best solution. And there's a lot of places where that's true today. And again, if you install a heat pump today, every year it actually operates cleaner and cleaner as the grid is getting cleaner. If not, you still need gas for heat. Make sure you're pairing it with a heat pump. And you get a dual fuel system where you get that technology in place and you're picking up that load for the remainder of the year. So, let's make sure we're not waiting for perfect. We will get there, but put points on the board today and start making some progress with decarbonization. So thanks again for USGBC, Texas, and EarthX, and happy to talk with you that might have more questions afterwards.
Okay. Well, I want to thank all of our speakers. Thank you for the innovations. Thank you for the impact you're making on sustainable development. And let's have one last big round of applause for our 6 speakers.